If you stepped outside tonight and looked up, the night sky wouldn't just feature a pale moon and scattered stars. Instead, a towering, luminous arch of ice, rock, and dust would span from horizon to horizon, catching the sunlight and glowing like a permanent ribbon across the cosmos. Having rings like Saturn wouldn't just change our postcard views, it would reshape our climate, our navigation, and our place in the solar system. To understand how Earth could get rings, we have to look at how Saturn got its own. Celestial bodies are held together by their own gravity, but when a smaller object gets too close to a much larger planet, tidal forces come into play. The gravity pulling on the near side of the moon is significantly stronger than the gravity pulling on the far side. If the moon crosses a boundary known as the Roche limit, these tugging forces beat the object's internal gravity, ripping it apart into trillions of fragments. For Earth, the Roche limit for an icy moon is roughly 11,000 miles above the surface. If a medium-sized icy body or even our own moon were to drift inside that line, Earth's gravitational grip would tear it to pieces. Over several months, those scattered fragments would collision dampen into a thin, flat disk orbiting around Earth's equator. What this ring system looks like to you depends entirely on where you stand on the planet. At the equator, because the rings align directly overhead, you wouldn't see a massive arch across the sky. Instead, you would see a bright, razor-thin line cutting straight up from the eastern horizon to the western horizon, almost like a glowing seam holding the atmosphere together. As you move away from the equator toward temperate latitudes, like New York, London, or Tokyo, the perspective opens up dramatically. The rings would spread across the sky into a massive, shimmering arc, broad and detailed, reflecting brilliant sunlight even after sunset. In the far polar regions, the rings would appear low on the horizon, resembling a gentle, luminous mountain range of dust and ice off in the distance. While the visual shift would be breathtaking, the environmental consequences would be staggering. Rings aren't transparent. They cast vast, dense shadows onto the planet's surface. Depending on the time of year, Earth's rings would block a significant portion of sunlight from reaching temperate zones. In regions accustomed to warm summers, the permanent shade of a ring shadow could drop regional temperatures noticeably, altering weather patterns and shifting agricultural growing seasons. Photosynthesis in plants located under long-term ring shadows would slow down, forcing ecosystems to adapt to reduced sunlight. The shadow would also alter global ocean currents and atmospheric wind belts, creating unexpected weather extremes in places that currently enjoy mild climates. Nighttime would also undergo a massive transformation. The sheer amount of reflected sunlight from an icy ring system would make Earth's nights much brighter. Instead of true darkness, nights under a full ring shine would look like a deep twilight. Nocturnal animals that rely on complete darkness to hunt or hide would face intense evolutionary pressure, while human light pollution concerns would pale in comparison to the natural glare from the sky. For human civilization, rings would present both inspiration and immense technological hurdles. Modern space exploration would look entirely different. Rocket launches through a thick field of orbital debris would be extremely hazardous. The dangerous zone around the equator would act like a barrier, making satellite placement in low Earth orbit much more difficult and forcing space agencies to launch from polar trajectories. Satellites in geostationary orbit would risk frequent collisions with ring particles, potentially preventing us from ever developing the dense global communications networks we rely on today. On the other hand, early human history would have been profoundly influenced. Ancient cultures wouldn't just map constellations, they would build mythologies around the celestial arch, using its changing shadows to mark seasons and navigate across featureless oceans. Ultimately, Earth's lack of rings isn't a missing feature, but a condition that allowed our biosphere and space-age technology to develop as they have. A ringed Earth would be visually magnificent beyond words, but it serves as a powerful reminder that our world's balance depends on the precise, quiet stability of the space surrounding it.